Today we're going to look at doing the wrap lesson on linear systems. This is where we have two equations and we solve for both the x and the y variable. There are two methods we learned to solve linear systems: elimination and substitution. The first four problems work best with substitution, and then the last four work best with elimination before we get to the word problem. So I'm going to do one substitution problem, show it to you all the way through, then ask you to complete problems 2, 3, and 4 while your teacher pauses the video. Once you've had enough time to complete 2, 3, and 4, your teacher can start the video again. I'll go over the answers to those and then explain problem 5. Teacher will stop the video, you will complete problems 6 through 9, and then I'll come back on and go over those answers. So the first problem is substitution. When you substitute, you take something from one equation and plug it into the second equation. For substitution to work, you must have one of the variables by itself. In this first problem, the x is by itself. If you do not have one of the variables by itself, you need to move the pieces around in the equation so you get one by itself. So, first equation is solve for x. In the second equation, everywhere I see x, I'm going to plug in 2y minus 5, or plus negative 5. And then the plus negative 1y still stays, and it all equals 11. Distribute through the parentheses, so 4y plus negative 10 plus negative 1y equals 11. Combine our like terms of our y values. That gives me 3y plus negative 10 equaling 11. Add 10 to each side. 3y equals 21. Divide both sides by 3. And y is 7. Now that I know that y is 7, come back up to my first equation and plug 7 in everywhere I see y. So x equals 2 times 7 plus negative 5. That's 14 plus negative 5. So x is 9. Your final answer needs to be written as the ordered pair, 9, 7. At this point, the teacher is going to stop the video, and I would like you to try problems 2 through 4. Now that you've had a chance to complete problems 2 through 4, we're going to go through and go over the answers. I'm going to set up the problem, kind of go through and solve it. In the first one, we need to get this y by itself right here. So the first thing I'm going to do is I'm going to add 2x to each side. When I do that, it should be a negative 2x I'm adding to each side. I get negative 1y equaling negative 2x. I want the y by itself, so I need to divide by the negative 1. So y is 2x. In my second equation, everywhere I see y, I'm going to plug in 2x. So x plus 3 times 2x equals negative 56. X plus 6x, when you distribute, equals negative 56. Combine my like terms, 7x equals negative 56. Divide each side by 7. And we get that x is 8. Now that we know that x is 8, plug it back into the original top equation in order to figure out what y is. So 2 times 8 plus negative 1y equals 0. 16 plus negative 1y equals 0. Subtract 16 from each side. And negative 1y equals negative 16. Divide each side by negative 1. And y is positive 16. And I did that all wrong. My x should be negative 8, because negative 56 divided by 7 gives me negative 8. So when I go to check and figure out what y is, all of that's going to change, and I get negative 16 as my answer. So a simple little sign problem way back closer to the beginning actually ended up throwing me off decent way through the problem. And this is why checks are always important. So your final answer becomes negative 8, negative 16. Problem 3, we already have the x by itself, so everywhere I see x, I'm going to plug in 6 plus negative 4y. So 2 times 6 plus negative 4y plus negative 3y equals 1. That's 12 plus negative 8y plus negative 3y equaling 1. Combine my like terms, so 12 plus negative 11y equals 1. Add negative 12 to each side. Make sure to watch your signs. Negative 11y equals negative 11. Divide both sides by negative 11. And you get y equaling positive 1. Now that I know what y is, I'm going to plug it back in to find x. X equals 6 plus negative 4 times 1. 6 plus negative 4. X is 2. Final answer, 2, 1. Number 4, I don't have a whole lot of room to write, but I'm going to write over here to the side. I'm going to solve this second equation for that x right there. So I'm going to add negative 7y to each side. Remember that the negative 7y and the 10 cannot go together. So x equals negative 7y plus 10. Everywhere I see x, I'm going to plug that in. So 3 parentheses negative 7y plus 10 plus negative 4y equals 5. Distribute negative 21y plus 30 plus negative 4y equals 5. Combine my like terms, negative 25y plus 30 equals 5. Subtract 30 from each side to get the y by itself. Negative 25y equals negative 25. Divide each side. And you get y equaling positive 1. Now that we know that y is positive 1, I need to figure out what x is. I'm going to change colors, and I'm going to write over here on the left-hand side because I got a little more space over here. So x plus 7 times 1 needs to equal 10. X plus 7 needs to equal 10. Subtract 7 from each side. And you get x equaling 3. Final answer needs to be written as the ordered pair, 3, 1. So 5 is where we're going to switch, and we're going to switch to the elimination method. With the elimination method, this is where you want to take the two problems and you want to set them on top of one another. Line them up so that your x and your y variables match up vertically. Now we're going to add. You want one of the variables to cancel. If one of the variables will not cancel, you may multiply one or both equations by any number you like in order to get something to cancel. In this problem, though, my 3x's will cancel. I'm going to add 2y and 1y is 3y equaling 6. Divide by 3, and you get y equaling 2. Now I'm going to plug that into one of the two original ones, doesn't matter which one, in order to figure out what x is. So negative 3x plus 2 equals 0. Subtract 2 from each side. Negative 3x equals negative 2. Divide both sides by negative 3, and you get x equaling the fraction 2/3. It is fine that it equals a fraction. Do not change it into a decimal. Just leave it as 2/3, and your final answer is 2/3, 2. Now your teacher's going to pause the video. I'd like you to try 6 through 9. I'll give you a few minutes, and then I'll come back and we'll go over them. So now for problem 6, we're going to line them up again. Negative 3x minus y equals 6. You'll notice my y's, again, are close to canceling each other out. I need to multiply this bottom one through by a negative 1. When I do that, the top equation stays the same. Negative 2x plus negative 1y equals negative 4. And 3x plus 1y equals negative 6. My y's cancel out, and I get 5x equaling negative 10. Divide each side by 5. and x is negative 2. Now I'm going to plug back in and try to find y. Negative 3 times negative 2 plus negative 1y equals 6. 6 plus negative 1y equals 6. Move the 6 to each side by adding negative 6. And I get negative 1y equaling 0. 0 is a number. It's perfectly okay to get 0. You're still just going to divide each side by negative 1. 0 divided by negative 1 is 0. Final answer is going to be negative 2 comma 0. Problem 7, we're going to go ahead, we're going to line them up again. So 3x minus 4y equals 2. I'm going to multiply the entire bottom equation through by a negative 4. Top equation stays the same. 2x minus 16y equals 8. Bottom equation, negative 12x plus 16y equals negative 8. What you should notice is everything cancels out. And on the left-hand side you have 0, and on the right-hand side you have 0 because there's nothing left. What's nice, though, is the two zeros match each other. And if the two numbers match and all your variables disappear, you actually get the answer of infinitely many solutions for number 7. Number 8, it's actually set up very nicely as a substitution problem. So I'm going to plug in for y. So, start with the 6. 6x plus 2 times 2 minus 3x equals 7. 6x plus 4 plus negative 6x equals 7. My 6x and my negative 6x cancel out, and I get 4 equaling 7. These two numbers do not match, so my answer is no solution. I'm not quite sure I have that extra line there. No solution. Problem 9 is our word problem. You have to get the two equations set up. In this case, we're looking at what happens on Monday, and we're looking at what happens on Wednesday. On Monday, we bought 4 cups of coffee. We'll make X represent coffee, and we bought 8 bagels, and we'll let Y represent bagels. And our total, or our dollar amount, was $8.77. On Wednesday, our total was $15.80. 8 cups of coffee, we said that coffee was X and bagels are Y. So 8X plus 14Y. They're already set nice and neatly on top of each other for you for elimination. I'm going to multiply the top equation by negative 2 in order to get the x's to cancel out. I'm looking to get the x's to cancel out because I'm looking for the price of a bagel. I don't need to know the price of a coffee. I just need the price of a bagel. And bagels are represented by the y variable. So I can actually do less work if I can get the x's to cancel out. So negative 8x plus negative 16y equals negative $17.54. Bottom equation stays the same. Now I'm going to go ahead and add. When I add, I get negative 2y equaling negative 1.74. Divide each side by negative 2. Remember that two negatives go positive, and I get y as 0.87, or 87 cents per bagel, as my final answer. If you have any questions on anything with linear systems, please make sure you come see me, star things on your papers, whatever you need, but make sure you come get some help. And that's the end of this lesson.